Hi everyone, welcome to the leetcode POTD, and today we are gonna solve max chunks to make sorted array. So basically we are given an integer array of length n, and that represents different permutations of integers which is range from 0 to n minus 1, and where n is the length of the array. So we split array into some number of chunks, that is partitions. So we have to split the array into some number of partitions and individually sort each not short sorry sort each chunk. And after, like, first we have to divide partition it in a way, and then after that we have to, after partitioning each chunk, like the array, into different partitions or chunks, we have to sort that individual partitions or chunks, and then after concatenate, then you have to concatenate them. Okay, and after we concatenate, now the result should be equal to the sorted array. That's what the question says. So see, here if you can see, after concatenating them, the result should equal, like, first we have to break the array into different chunks or partitions, and then we have to sort each of this chunk, and then we have to concatenate them, like bring back together, so that it forms a give a final sorted array. And you have to return the largest number of chunks that can be made from the sort the array. So this question is actually based to, this question was made to, for solving it with a monotonic stack, but there is also another observation or catch if you can get it. So basically here the simple solution here you can get is this one, which is a brute force and the observation, like if your IQ is in great, sorry, not just saying like that way, but yeah, this simple observation, if you just made that, then you're good to go. So basically in, like, this is very simple. Like, what I have got actually, that if you are adding up the index, and as well as, like, you are doing taking the prefix sum of the index from 0 to n, and again some summation of the prefix sum of this array, and then if all of these are equal, then either, like, we should answer plus plus and then finally return the answer. Okay, so I'll make you understand how. Okay, so this is the simple one example. So here, if what I said, you have to, what I have taken at first, like, some prefix sum of the index. So of course 0 base indexing, 2 3 4, right? That's it. So the summation of the index will be 0 1, then 3 6 and 10. Okay, and here summation of the array, right? So this is 1 and this is 1, this is 3, because 1 and then 1 plus 0 is 1, and 1 plus 2 is 3, 3 plus 3 is 6, then 6 plus c, I'm doing it from here, 6 plus 10 is 10, 4 is 10. So basically you can see 1 is here, 4 of these are equal except 0 and 1 is not equal. So if any of the index prefix sum of the index is equals to the prefix sum of the array, then answer plus plus, like, increase the counter and then finally return the answer. This is a very simple, and if you just can observe that, you are good to go. This is actually the most optimal solution, which is having the time complexity of big of n and space complexity, of course, big of 1, because we did not take any that extra space to store anything, and only one single for loop is running here, right? So after that, now we will be going to the best solution, like, not this is the best for, like, the most optimal, but like, you should also solve this question using monotonic stack. I'll show you how. So here, if you see in leetcode, they have showed, like, the main idea of this approach, that, like, the main idea, if you see, if you observe a bit here, again taking this example too, last video yesterday we have learned how to solve using monotonic stack, and what are those last or previous video, whatever. So but here you can see that, see, I'm using a stack or monotonic stack. So suppose 1 is in the top of the stack, right? So now 0 is there, 0 is less than 1, so let's not take 0. Okay, because see, our main outcome should be like 1 0, right? This can be one partition, and again 2 3 4. Can it be? So I'll tell you how you can make maximum, like we again remember always, like we have to find return the largest number of chunks. Okay, maximum number of chunks. So since 0 is less than 1, so what we will do? We will just stop there. Because see, this can be one partition. Then this, because we have our task main aim is to find the largest. So 1 2 3, 1 2 3 4 partitions are there. These are the thing, right? Now if you sort 0 and 1, and therefore they are not asking you to return you the final array, they are just asking you the number of chunks that you can make. So don't worry about that, like you have to sort and all. So basically you can do 0, like after sorting this, then it will be in sorted manner, right? 0 1 2 3 4. So therefore this is the number of partitions you have to do. But how to solve this in monotonic stack? Because you have to be greedy here, right? So see, 1 is in the top of the stack. As soon as we see any element less than the top of the stack, then we will just not take that and remove that also. So 1 was in the top, and then 0 came. Since 0 is less than 1, so we are not gonna take, and we will also remove 1. Okay, but again you have to take something, because you have to check with the next element. So we will take 1. Since this is the maximum element, there was no other elements to which we can check, compare. And then again 2 is this time more than 1, so we will take 2. So the top of the stack will be 2 1. And then yeah, again 3 is more than 2, right? 3 is more than 2, so we will take 3 as well. And again 4 is more than 3, so we will take 4. See, the simple catch here is that every time a smaller number comes, because the sorted array should be like, see here it's a smaller number, so you have to sort it. So 1 chunk, again a greater number, this number is small and smaller than this will be 1 chunk. This is simple catch to find the largest number of chunks actually, because here we can sort this, and then this is 1 chunk, this, right? That is why. So here ultimately we will return the size of the monotonic stack, that is 4. Of course 4 integers are there, so the final answer is 4, right? Definitely. See the solution code once. Very simple. Stack, just taking a stack and then running a for loop and checking if the top, like till the stack is not empty. At first you have to check that. And also the what is it, new array should be more than the top of the stack, then push it in the stack. Else if it is not, then max element of the monotonic the max element will be the top of the stack, because here we have to, if this condition is not matching, then you have to remove the array na. But since we have to compare, if you remember, is in this part we have removed 1 and 0, but since we have to compare, that's why we are finding the in stack all, like this is a monotonic stack, and always in the top there will be the largest number. Therefore we are taking max element as a monotonic stack top, and jab tak it's till our stack is not empty and the new array is less, then of course here it will be less than the top of the stack, then we will just pop it. Then again we will push the max element that was the top element, so that if you do not have anything, if the stack is empty, how we will compare it with the next elements. That is why we have taken max element top here and then again pushed it. So as simple as that. I hope you understood. And the time complexity for the monotonic stack is of course big of n, and big of n for big of n the time complexity, and for space complexity it's big of n. Definitely we are taking a stack space to store this, and we are using a single for loop again to iterate in the array. So yeah, I hope you understood today's POTD, and yeah, keep solving, keep grinding. Bye.